This is a very interesting question. On a frictionless horizontal surface to be xy plane, a small trolley A is moving a straight line parallel to y-axis with a constant velocity of square root of 3 minus 1 meter per second as in figure. So this is xy plane. A trolley is moving parallel to y-axis at an angle of, later will be given, that is angle of 45 degree. At a particular instant, when the line OA makes an angle of 45 degree with the x-axis. So at this instant, a ball is thrown along the surface from the origin O. Its velocity makes an angle phi with the x-axis and it hits the trolley. First, the motion of the ball is observed from the frame of the trolley. Calculate the angle made by the velocity vector of the ball with the x-axis in this frame. And B part, find the speed of the ball with respect to the surface if phi is given as 4 theta divided by 3. In this question, it's a combination of both relative velocity as well as a projectile. So we are going to use both the things. So first, we are again going to draw the figure. So this is x-axis and this is y-axis. This is trolley A and it is making an angle of 45 degree with the x-axis. So at this instant, a stone is thrown such that it hits the trolley and trolley is moving in this direction. Okay. So what we do, we say that let VA is velocity of trolley and VB is velocity of ball. Now it is given that the ball hits the trolley. It's given that ball hits the trolley. So if the ball hits the trolley, we can say that relative velocity of the ball implies that relative velocity of ball, which is given as VBA, must be in the direction or along, rather in the OA direction, or we can say along OA. So this, if it is in the direction OA, then the angle made by it with the x-axis will be 45. We can say that this relative velocity vector VBA makes angle of 45 degree with x-axis. So this is our A part. In the B part, we find out, or rather we write the x-axis component of VBA as V vector VBX, and we write y-axis component as VBA y. But VBA makes angle of 45 degree with x-axis, so we can clearly say that VBA, or we can say, let's call this 1, as per condition 1, we can write that both the components, the x-axis component will be equal to y-axis component. Now, using the actual formula of relative velocity for both x as well as y, we can write VBA x will be equal to relative velocity of B with respect to ground in x direction minus relative velocity of B in y direction. But relative velocity of B in y direction is 0, so this can be written as VBx. Similarly, we can write it as the second part, VBA y is equal to relative velocity of B with respect to ground in y-axis will be relative velocity of ball. Sorry, here it has to be A, my mistake, A and y. So we can write this as VB y minus, and its value is given as square root of 3 minus 1. Okay. Now it is given that VBAx is equal to VBAy. So we can equate both these equations. Let this be 2 and let this be 3. From equation 2 and 3, we can write that VBx is equal to VBy minus square root of 3 minus 1. From here we can find out what will be VBy is equal to VBx plus square root of 3 minus 1. Now it is also given that the ball makes an angle of 45 degree with the x-axis. So ball makes angle of phi with x-axis. So we can write it a tangent of phi is equal to VBy divided by VBx. From here we can find out VBy. So VBy will be equal to VBx multiplied by tangent of phi. So we have two equations of VBy. This is, let us call this as equation, and the previous equation was VBy is equal to VBx plus square root of 3 minus 1. So we can equate them. So this will be coming as VBx tangent of phi is equal to VBx plus 3 minus 1. So from here we take this into the left side, so we can write this as VBx, taking this a common. This will be tangent of phi minus 1 is equal to root 3 minus 1. From here we can write VBx is equal to root 3 minus 1 divided by tangent of phi. In the question it is given that phi is equal to 4 theta divided by 3, and theta is nothing but 45. So 4 multiplied by 45 divided by 3, so we get phi as equal to 60 degree. We substitute here, we get root 3 minus 1 minus 1 divided by root 3 minus 1. So this cancel and this will be coming as 1 meter per second. So VBX is 1 meter per second. And similarly, we can find out VBY. So VBY will be equal to root 3 minus 1 divided by tangent phi minus 1 into tangent of phi. So this, we already know this value is 1, and we can write 1 into tan 60, which is equal to root 3 meter per second. So we have the x component as well as y component of the ball. So we can find out its vector as VB x square plus VB y square and its square root. Substituting the values, 1 plus square root of 3 whole square. So this will be equal to 1 plus 3 square root and square root of 4. So we get VB as 2 meter per second. Thank you.